This video is about finding the area of composite figures and shaded regions. So first we're going to find the area of a composite figure. So in number 1, we have a triangle on top of a trapezoid. So we're going to find the area of both of those and add it together. So before we can do that, we need to find a couple of missing pieces. So the first thing we need to find is the height of the triangle. So if we focus on one of these triangles with the leg of 10, and the base of 6, we can do Pythagorean theorem to find our height. So we have 10 squared equals 6 squared plus x squared. We get 100 equals 36 plus x squared equals 64, which means x is 8. So our height is 8. Then we also need to find the height of the trapezoid. So we know that because both legs are 10, that the base of the triangle is bisected into 6 and 6. When we draw in our heights of the trapezoid, we create our rectangle, so we know that this part has a length of 8. If the triangle is 6 and 6 on the bottom, that means the whole length of the base of the trapezoid is 12. So we can do 12 minus 8. And when we do 12 minus 8, we get 4, and we split that into 2 and 2, so we can find the height of our trapezoid. So we get 5 squared equals 2 squared plus x squared. 25 equals 4 plus x squared, so 21 equals x squared. X is the square root of 21. So we have our height is the square root of 21. Now that we have all of our information, we can find the area. So to find the area here, it's going to be the area of the triangle plus the area of the trapezoid. So the area of the triangle is 1/2 base times height. Remember, our base is this whole segment. So it's going to be a length of 12 times a height of 8. To get our trapezoid, it's 1/2 times the height, which is the square root of 21, times base plus base. So remember, again, our first base on with the 6 and 6 is 12, and the second base is 8. So we're going to add those bases together. So when we do that, we have 1/2 times 12 times 8, which is 48. And then we have 1/2. We're going to leave the square root of 21 off for now. So we're just going to do 1/2 times 12 plus 8, which is 10. So we have 10 root 21. Those do not combine together, so we're going to say inches squared. Number 2, we have 2 triangles and a rectangle. So we need to find some of the missing information first before we can find our area. So I want to know what the whole length of this triangle is. Pythagorean theorem, 51 squared equals 24 squared plus x squared. Get 2,601 is equal to 576 plus x squared. We can subtract that from both sides, and we get 2,025 equals x squared. And we take the square root, we get that x is 45. So if the whole side of the triangle is 45, but this piece is 4, that means part of the rectangle is 41. Then we can use our other triangle to find the other missing side of the rectangle. So we have 10 squared equals 6 squared plus y squared, or x squared again, we can call it, that's fine. So we get 100 equals 36 plus x squared, 64 equals x squared, so x is 8, which means the other side of the rectangle is 8. So now we can find our area. We have the area of the triangle plus the area of the rectangle plus the area of the triangle again. So the first triangle on top, it has a base of 45 and a height of 24. So we have 1/2 24 times 25, or 45, plus the area of the rectangle, which is 41 times 8, plus the other triangle, which is 1/2 6 times 8. So 1/2 times 24 times 45 gets us 540. 41 times 8 gets us 328. And then 1/2 6 times 8 gets us 24. Those are all constants, so we can add them together, and we get a combined area of 908 centimeters squared. Number 6 is a weirdly shaped, kind of got a bunch of rectangles going on. So what we can do is we can find the area of the whole rectangle and then take away these little pieces that we're forming into smaller rectangles. So in order to do that, we need to figure out what the side of the whole rectangle is. So we know that this whole side is going to be 13. This whole side, we have 8 and we have 14, and then it cuts in for 2 centimeters. So that length is going to be 2. If we add that together, so 8 plus 2 plus 14, we get a length of 24. We know that this rectangle is 2 by 2. This rectangle is 1 by 7. This rectangle has the same height as here. So I can just slide that over. So we have a height of 7. To get this bottom side of the rectangle, we know so far that we have a length of 2, 1 for this little part that was cut in, and 15. We can take those away from 24, so 24 minus 2 minus 1 minus 15 gets us a length of 6. So we're going to do the area of the larger rectangle, which is 13 times 24, and then we're going to subtract the other 3. So I'm going to subtract this one, which is 2 times 2. We're going to subtract this rectangle, which is 1 times 7, and we're going to subtract this rectangle, which is 7 times 6, because those are cutouts to the shape. So 13 times 24 is 312. 2 times 2 is 4, 1 times 7 is 7, and 7 times 6 is 42. So we can subtract 312 minus 4 minus 7 minus 42, and we get 259 centimeters squared. In number 4, we have a shape that looks like a house. So we have the main building is a rectangle, the roof is a triangle, and then we have this little trapezoid that is a chimney. So what we can do here is we need to find the height of our triangle. So we know that this side is 32, and because of this 20 over here, it means that the side of the roof is congruent. So it's an isosceles triangle. So this splits into 16 and 16. So we can do Pythagorean theorem to find the height. So we have 20 squared equals 16 squared plus x squared. So we get 400 equals 256 plus x squared. We can subtract and we get 144 equals x squared. Take the square root, x is 12. So now we have all the information to find our area. So the area of the rectangle is going to be 32 times 24. The area of the triangle is going to be 1/2. 32 is the base, height is 12, plus the area of the trapezoid. So the trapezoid is turned on its side, so its bases are 1 and 2, and this is going to be the height. So we would have 1/2 times the height of 1 times 2 plus 4. So the area of the rectangle then is going to be 768, plus the area of the triangle, which is 192, plus the area of the trapezoid, which is 3. If we add those numbers together then, we get 963 feet squared. Now let's look at shaded region. So in a shaded region, you need to take away whatever is not shaded. So in number 5, we have all these circles, which means everything is congruent. So all of these sides are going to be 32. So we have a square and we have an equilateral triangle. So to find the area of our shaded region, we're going to do the area of the square minus the area of the equilateral triangle. So a square is just side times side, so 32 times 32. To get the area of an equilateral triangle, there's a formula for that. Remember, it's root 3 over 4 times your side squared. So when we do our area, 32 times 32 is 1024. Over here, we're going to do 32 squared divided by 4, so we get 256 root 3. 1 is a constant, 1 is not, because we're looking for exact answers. We're going to leave it as is. Number 6, we have a trapezoid with a triangle inside it. Now, the problem is we don't know the height of our trapezoid yet, which is actually also the height of the triangle. So to find that, we know this base is 6 and this base is 12. So if we bring the 6 down, we know that this length is 6. So each part of the triangle is 3 and 3. So we can do Pythagorean theorem to find the height. So we have 5 squared equals 3 squared plus x squared. So 25 equals 9 plus x squared. 16 equals x squared. So x is 4. So the height of our trapezoid is 4, which is also the height of our triangle. So now we can do the area of the trapezoid minus the area of the triangle. So the area of the trapezoid is going to be 1/2 the height, which is 4, times base plus base, so 6 plus 12, minus 1/2 the base of the triangle is 4, the height of the triangle is 4. So when we multiply, we have 1/2 times 4 times 6 plus 12, which gets us 36. And then we have 1/2 times 4, which is 8. So when we subtract, we get the area of the shaded region then is going to be 28 centimeters squared. In number 7 then, we have a triangle with 3 parts that are not shaded. So in this triangle, our whole side is going to be 17 because 12 plus 5, and on the bottom it's going to be 28 because it is 16 plus 12. But we need to get the rest of the dimensions. So if I bring 16 up here, I have one triangle then that is 12 by 16, a rectangle that's 5 by 16, and then another triangle that is 12 and 5. So we can do our area. So we're going to do the area of the bigger triangle, 1/2 17 times 28, and then we're going to subtract the other 3 pieces. So the first piece is going to be 1/2 12 times 16. The second piece is going to be 16 times 5, and the third piece is going to be 1/2 5 times 12. So 1/2 times 17 times 28 is going to be 238. 1/2 times 12 times 16 is 96. 16 times 5 is 80. And 1/2 times 5 times 12 is 30. We can subtract those from our larger area. And when we do, we get that the shaded region is going to be 32 yards squared. In number 8, a picture frame is 8 by 11. It has a 2-inch metal border. So our picture is 8 by 11, and we're going to have a 2-inch border. So going up and down, we're going to add 2 inches to the top and 2 inches to the bottom. So 11 plus 2 would give us that this whole height of the picture frame is 15. And then with the 8, we're going out to each direction. So 8 plus 2 is 12. So to find the area of the frame, we would do the larger rectangle, 15 times 12, minus the smaller rectangle, 8 times 11. And we get 180 minus 88, which is going to be 92 inches squared.